Hello guys, we are going today to define three new concepts, which are increasing function, decreasing function, and the first derivative test. We begin with the definition of increasing function. What is the meaning of increasing function? We mean that for any two values of x, x1 and x2 such that x1 less than x2, this implies fx1 less than fx2. What we mean by fx1, it means y1. What we mean by fx2, it means y2. The corresponding y to x2 and the corresponding y1, the corresponding y of x1. Look here. What is the meaning of this one? It means as x increase, y increase. Okay? The graph in this case like this one, x increase, y increase. In this case, the behavior of the function is increasing on this interval. Okay? If a function is decreased on an interval for any two numbers x1 and x2 in the interval such that x1 less than x2 implies fx1 greater than fx2. It means y1 greater than y2. By another way, it means as x increase, y decrease. The graph of the function looks like this one. As x increase, y decrease. That is the meaning of increasing or decreasing function. Now, I'd like to illustrate the meaning of theorem 4.5. Test for increasing and decreasing function. Let f be a function that is continuous on a closed interval and differentiable on the open interval AB. Look here. We have a relationship between the value of the derivative on the interval and the behavior of the function on this interval. Example, if the derivative of the function greater than 0 for all x in the open interval, then the function is increasing on the closed interval. If the derivative of the function for all x in an open interval, AB, then the function it will be decrease. We have a relationship between them. If the derivative greater than, so the function is increasing on this interval. If the derivative less than 0 or negative, so the function is what? Decreasing on this interval. If the derivative equals 0, so the function is constant. I'll show you on the graph. Here, for the branch of this function, at the left here, as you see here, look at this part, the tangent here, the slope of the tangent for this part of the function, its slope is negative. Since its slope is negative, so the function the derivative of the function less than 0. And the behavior of the function is what? Decreasing. As you see, decrease. As x increase, y decrease. When the derivative of the function less than 0, it means negative, so the function is decreasing. Okay? If the derivative of the function more than 0, positive, okay, on an interval, so the function is what? Increasing. If the derivative 0, so the function is constant. I'll show you how to apply all of these concepts to solve problem. Okay, to solve what? Problem. Here, I'd like to tell you something. Please focus. If we have a critical number in an interval, okay, and the function differentiable on this interval. As you see here, if we have a critical number C, please be careful. At the critical number, the function okay, maybe has relative maximum, relative minimum, or does not have any extrema, neither relative minimum or nor relative maximum. It means not at each critical number we have extrema. When we have extrema, if the behavior of the function changes around this critical number. As you see, if we have a critical number c, the behavior of the function around this one change from decrease to increase. So the function here, it is what? Minimum, relative minimum value. Also, around the critical number c, if the behavior of the function change from increase, it will reach to the maximum value, then decrease. So the function, it has what? Relative maximum. If the behavior of the function change around the critical number, change from positive to negative at this critical number, so we will have extrema, relative maximum or relative minimum. But if the behavior of the function does not change, in this case, we don't have any extrema, or neither relative minimum nor relative maximum. As I'll show you here. If you have a critical number here, as you know, we have a horizontal tangent. The behavior of the function for all of the values of x less than c is increasing. And for all of the values of x, okay, the function is what? Greater than c, the function is increasing. Since the behavior of the function does not change around the critical number, in this case, the function has neither relative minimum nor relative maximum. By the same way, in the last example here at the critical number, here around it, the function here decrease, as you see, and here what? Decrease. As x increase, y decrease. As x increase, y decrease. In this case, the function has neither relative minimum nor relative maximum. Okay, so the condition to have critical extrema, it occurs at critical number such that the behavior of the function, it changes from increasing to decrease or decrease to increase. Now, for example number 1, we have to read the head of the question well. He asks you to what? Let's read the question together. Use the graph to estimate the open interval on which the function is increasing or decreasing. Then find the open interval analytically. Analytically, it means show me the steps that you use. Because sometimes I will give you the function without the graph. But I have to identify from the graph and without the graph, from the rule of the function. Okay? The beginning, I have to identify where is the critical number. What is the meaning of critical number? The values of x at which the derivative equals 0. It means the function has a horizontal tangent. Okay, or the critical number occur at extrema occur at critical number, but not each critical number. At each critical number we have extrema. Okay. Now, as you told me in the morning in the live session, where is the critical number at this extrema, which is the minimum, relative minimum? 3. It's so clear. As you see the number line x here, the smallest value negative infinity, and here infinity. The critical number divide this number line into 2 parts, okay, or into 2 intervals. The first interval is what? Negative infinity, all of the values of x between negative infinity and 3. Then all of the values of x between what? 3 and infinity, because as you know, we have to write the smaller number in interval. Okay? It's so easy. As x increase in this interval, y decrease. So the function is decreasing. In this case, f(x) is decreasing on negative infinity 3. Okay? And here on this interval, as x increase, y increase. f(x) decrease, I write abbreviation for is decreasing on what? 3 and infinity. That is from the graph. It's so easy, so clear. Identify what is the critical number on the x-axis at which we have extrema, which divide the x-axis into two intervals if we have one critical. 2 critical will divide into 3. 3 critical will divide into 4. Number of critical numbers divide the number line at the x-axis into number of intervals more than the number of critical numbers by 1. Okay? I think it's easy. This one how to identify by using the graph. But now I'll show you how to find the interval in which the function is increasing or decreasing analytically. I'll show you my steps. And I solve it in the revision sheet by another steps, but it is the same. Okay? The first step here, find what? The derivative. In the worksheet, you will find the explanation. You don't need to write, but my explanation I wrote already in the model answer of worksheet 7. Find the derivative. That is the first step. I told you in the revision, or I wrote, find the derivative. Differentiate. Okay, equal. What is the derivative? 2x minus 6. Second step, find the critical number. Means why you do this, you write these steps. If we don't have the graph, if we don't have what? The graph. I have only the rule. Okay? Now, find the critical number by equate the value of the derivative by 0. The derivative by 0. So, 2x equal 6 implies x equal what? 3 is the critical number. Third step, as you see here, I write this one. Okay? Then write here what? 3. The critical number divide the number line into 2 intervals. Okay? Here I choose values. Here this line for what? First derivative. This line of what? First derivative. Clear? Okay. I use the first derivative test. This means I have to use the derivative only. Choose value. I name it test value. What is the test value? That is the fourth step. Use test value, which is what? I'll choose here any number in this interval, okay, which is negative infinity and 3. Choose any value included in this interval, which is 1. I'll take 1. Okay? Then replace in what? In the derivative. It will be, you can substitute in the derivative, use your calculator. So the derivative, it will be at 1, it will be negative 4. Less than what? 0. So the function is what? Increase or decrease? The function is decrease. Because the derivative, I know, if the derivative negative, so the function is what? Decrease. How I know? By using this test value. Just take any value in the interval, replace in this one. If it is negative, so all of the values of the derivative negative on this interval. And so the function is what? Decreasing. Okay? By the same way, I'll do in the second interval, which is what? 3 and infinity. Choose value, which I name it what? choose any number. I'll choose number 4. Okay? I'll choose number 4. Then replace in what? In the first derivative. It will be f prime at 4, the test value, which I choose it. I choose it. Because someone in the morning asked me, Miss, from where number 4? From where number 1? Just value, I choose it in the interval. It will be, if you use the calculator, it will be 8 minus 6, 2, greater than 0. It means positive. So the function is what? Increasing. The function is what? Increasing. Okay? In this case, I will write the interval. Here, decrease. On which interval? Okay. Fx is decreasing on which interval? Negative infinity to 3. Fx is increasing on 3 and infinity. It's so trivial. Okay? But if the function it changes from decrease to increase, in this case we have minimum or maximum. We have relative minimum at 3, but it is not requested here or not needed. I don't need it in this problem. Okay, that is in part 1. I'll take break and I'll continue to complete this worksheet.